Hello, this is Dr. Scott Denstead, founder of the EZWxBrief progressive web app. In this video, we're going to do a flight planning session for a early afternoon departure from Destin, Florida, up to Little Rock, Arkansas. And if you like this video and you want more of them, please take a moment to like and subscribe. It really helps to grow the channel if you are able to do that. All right, so this particular flight, we're planning this flight for a departure tomorrow. It is the evening prior to that departure. And for those that know and have done training with me, know that I spend a majority of my time the night before looking at the big weather picture, trying to understand that. And then I wake up in the morning and I'm just doing minor tweaks to the plan or the weather I saw the night before. So if I'm making this flight tomorrow here from Destin, Florida, ending up in Little Rock, we'll just assume at this point in time we're headed back home after a couple of days in Florida. I'm looking at this flight. Usually I'm breaking all the details down in the evening hours prior to that. So again, the whole idea is to stick with the big picture. Don't have a lot of details at this point. So I have to really focus on that big weather picture, and that's usually what I use to make my decisions rather than, all the little details that come into play. The little details are important. They fill in the gaps of information you need to make all the right choices. But for now, let's take a look at this particular flight as if we're going to try to make it back tomorrow in the early afternoon. At least that's our plan at this point in time. So as you can see here, this is valid basically at 18Z. That's when I have my departure advisor set up here in EZWxBrief. And you do notice that there is a fairly significant weather system making its way into the region or into my specific routes. And so what we have to understand is, what is the cause of this precipitation? We're going to make this trip in an airplane that take about 2 hours to fly there. It doesn't have a certified ice protection system, so we have to make sure we stay out of any icing conditions. And then we also need to probably do this trip under instrument flight rules. And so that's what we're planning to do for this trip. So if you are someone who fits into that kind of category, flying that kind of airplane, this particular video should be pretty helpful to learn how to use the EZWxBrief app to make these kind of decisions. Again, we're fine-tune things early tomorrow, but our goal is to wake up and expect to be able to depart sometime in the early afternoon. Let's take a look at what's happening overall, and I'll turn off the radar layer. We'll get to that in a second. I want to make sure that we can look at the details of what's on the map itself. So the layer I have selected is one I like, and that is the weather layer. It's under the station markers section here. And the reason why I use this is that it provides me with kind of the biggest bang for my buck. The colors here are for flight category, which involves looking at the ceiling and visibility, but it also shows you the weather type that's expected here, whether that's a showery precip symbol that you see down here, or the possibility of being non-convective precipitation. So you get the best of both worlds to know what's happening. So you can see immediately here, if you're departing out fairly early in the morning, 12:50Z, that's probably a 6 to 7 a.m. Time frame for local time. And then at this point in time, what we're going to do is watch what happens to that weather over the next several hours in the morning. And what you can see here is that there's a lot more of this low IFR, the magenta here, trying to move into this area. So we do know and we can see that the trend is for the weather to start getting worse with time. And as we get to 1920Z, if we leave at 18Z, and it takes us 2 hours to get there, by 20Z, we can already see that Little Rock, using the EZ forecast, is expected to have a ceiling of 400 feet and 1.5 statute miles visibility, which is considered low IFR conditions. Right now, not a whole lot of significant wind concerns, but from the standpoint of seeing the ceiling and visibility potentially dropping over time means that going into the afternoon hours, we expect weather to deteriorate pretty quickly, pretty rapidly in that time frame. And so trends are real important because I'd rather be in a situation where I'm headed toward an area where the weather is dissipating rather than potentially strengthening over time. So this is where we want to be real careful or potentially change our departure time to maybe something that's a little bit earlier. We hope to get out at 18Z or early afternoon, but maybe that's not going to be the case. We may have to wake up a little bit earlier and plan for a flight at a much earlier time frame than waiting to 18Z. So that's really what we're looking at here. And we could look at, I'm not going to go through each one of these layers, but it's certainly something you should do. You can look at your ceiling height so you can kind of see how that's playing out in terms of the actual ceiling height. You may have personal minimums that tell you that, hey, I don't do a instrument approach to anything that's less than 1,000 feet. And certainly this is a good way to deal with that. You do have the ability to know that if for some reason, if you were to head up in this direction and the weather was to be a little bit worse than you expected, you can always head back over here where the weather is showing, for the most part, pretty much VFR conditions. So that's your escape route if you need to go there. And planning for alternates should happen even if you're looking out several days in advance. You should start thinking about where it is I can go in the event that plan A doesn't work. And so this is a good tool to do that. There's also a personal minimums tool that you can also use as well for flight category. And this again is another way to say, hey, I've already set up for my destination, for instance, what are my personal minimums for flight category? And anywhere you see red, that means that it basically is busted through my personal minimums, valid at that particular time. And then anywhere you see green, that means that it's met my personal minimums conservatively. And yellow means that you met it personal minimums, but not necessarily with a lot of margin. So you're in that moderate risk area. So greens are where you want to eventually think about going. Doesn't mean that you have to go there. You decide to depart. You may end up finding another airport really close to Little Rock if there happens to be some issue. You're going to look at the current observations and all that at that time, but at least for the big picture that we're looking at now, the green areas are certainly safe havens if we can't make it all the way to our destination. So let's look at the big weather picture and hopefully get a better grasp of things. But first, let me just show you, and I'll turn this radar layer back on. This is a forecast radar layer from the high resolution rapid refresh model. And this will give us a better understanding of, from a standpoint of where the precipitation is expected to occur and kind of how it looks and how quickly it develops in a particular area. So we can see there's a pretty large shield. Let me zoom out here a little bit. And I'm going to put that weather layer back on. And I'd like to look at that when I'm looking at the radar layer itself. It gives me an indication of what kind of precipitation to expect, whether it's thunderstorms or showery precipitation, which is also convective, or looking at the possibility of just non-convective rain. And so you can see as I move the slider further in time, what you're noticing is that this area here is moving in pretty significantly over this entire route all the way through until we get to 21, 22Z. So essentially, the weather is expected to deteriorate over this time frame. It starts out initially as, and I'll zoom in here a little bit more, it starts out initially as a more cellular appearance to it. So you can see here, very much it looks like a very cellular appearance overall. So all the way through here. So that tells you you've got some convective process in place. It may not be deep moist convection in terms of thunderstorms, but you know that you probably have an enhancement in an atmosphere that's allowing air to move in the vertical. And again, we don't know why this is occurring. We don't know the big picture, but I just wanted to show it to you now so you can kind of see that and keep an eye on that. And then finally, by the time we get to around 20Z, about our time frame that we're planning to land, we do see that there's some pretty heavy precipitation moving in, along with some of those IFR conditions and even low IFR conditions over that area. So again, let's look at the imagery here so we can get an understanding of the big weather picture. So we'll go to the prog charts initially and see what this says. Kind of currently what's happening here is we have a coastal low with a warm front that's extending through here and an area of precipitation that's occurring right here with pretty much a high pressure over a good portion of the southeast and another area of low pressure up here north of the Great Lakes into southern Quebec and southern Ontario in Canada. And so let's take and watch this weather system evolve over time. So you see the area of low pressure there. I'll zoom in on this a little bit more. And there's a frontal system that are warm front moving through. Typically warm fronts, especially this time of year, tend to be fairly benign in the sense of having a lot of potential and a lot of convection. But you do see here in what's called the warm sector, here's the area of low pressure, and looks like a stationary front for now, but let's just say that's a cold front and a warm front here. Typically in this area here, we call that the warm sector, and that's where you have the most instability and therefore the possibility of seeing the most significant convective threats that may exist in this particular case. And we move this over until we get to a little bit too far there. This is the time frame for Sunday at 18Z. So this is the time frame we're planning to depart here on our trip from Destin all the way up to Little Rock, Arkansas in that general direction. And so this definitely shows that there's a high probability, a 55% or greater chance in that dark green area, that there's going to be non-convective precipitation moving in there, where we have essentially the convective precip tends to hang a little bit further south. So right now, it doesn't look like there's a lot of convection possible at 18Z. The next available time frame here is 6 hours later, and you do notice that 6 hours later by 0Z, check out what happens here. That convective area comes here a little bit further north into southeastern Arkansas. So again, our trip from Destin all the way over through here definitely looks like it moves through. So if we're later in the picture, you're close to 0Z, and that's the early evening time frame, this is going to possibly become a very serious situation. So we don't want to necessarily completely say there's not going to be any convective threat. That's moving into the area here. And because it's associated with a warm front and all those low IFR conditions, and even marginal VFR, these are all going to be embedded cells. So if it does eventually develop, these are going to be embedded thunderstorms or embedded convection in that region. I don't foresee this being a major convective outbreak here, but nevertheless, it still is something concerning flying a small airplanes in this particular area. And we do notice that eventually that does move through with time, and then all that convection moves a little bit further to the east, where the area where our departure airport is, certainly has that area that's becoming a little bit more significant in that region as that whole weather system moves through. We look at the 6-hour QPF. This tells us essentially how much precipitation is going to expect, or we expect to fall here. If we move this till we get to our time frame here, this is from 12Z to 18Z on Sunday, so this is the 6 hours prior to our departure, again, you can see the possibility of seeing some heavy precipitation moving through that area. Again, our route is really down through this region, we saw that in that forecast radar depiction that a lot of that was moving from the south west up to the northeast with time. All right, so if we look at the next, this is the 18Z to 0Z. This is the time frame we're looking to depart. Now this is over a 6 hour period. We do know that there's going to be a convective threat kind of moving in, so probably most likely a lot of this heavier precipitation, especially in the south eastern part of Arkansas, is likely to be mostly due to some of that convection moving in. So this, unfortunately, because of the 6 hour time smear here, likely most of it is probably going to be closer to that 0Z time frame than the 18Z time frame based on what we know so far. Next thing to look at is really the big weather picture really comes from what's happening aloft. I like to look at the GFS model and start out with the 500 millibar chart. And this gives me a better picture, a better feel for the overall issues with respect to, is there any upper level support with this? And so we see this is valid at 18Z this past afternoon. This next, the 0Z run of the model or the 18Z run of the model basically is what we see here. The 0Z run won't happen until much, much later. But nevertheless, we can see that we have an upper level low here moving in and kind of what essentially is a ridge poking up in this area here. So it's that's why we're getting some really nice weather in the parts of the southeast. But the next weather system possibly associated with that upper level low. So let's take a look and see how this is progressing with time. And you can see here that as we move this until Sunday morning, what we notice is that low, and don't worry about the time necessarily specifically, but you can see how it's starting to intensify, becoming a little bit more sharper and moving through into the Midwest and eventually up into the Northeast with time. So there is a period of time where it becomes a closed low, which is very common out of the southern Rockies to see that, and ultimately what it does is it turns into an open wave kind of a trough moving through with a significant V-shaped to it. So it's got some potency with this. So it is in a process of intensifying here over the next couple of days before it dissipates. So if we look at this from a standpoint of what's happening here as of 18Z on Sunday, what we see is that we have our what is essentially a positive tilted trough here, which generally is a little less intense when it has a positive tilt to it. But you do see, for the most part, here at 18Z, we see this vorticity pattern ahead of that. We have the height lines here that tend to diverge from each other, which creates an area where we get upper level divergence, and when air diverges aloft, something's got to come in to replace it from below, and so that you see that's how you get your lift from an upper level weather system. And so that divergence there with that vorticity pattern, which has a kind of cellular look to it here. I'll zoom in here a little bit more so you can see it a little more carefully. And so so in this particular case, you see we have a real speckled look to this vorticity pattern. By no stretch of the imagination is this not, this is not a huge upper level disturbance, but if there's enough instability, enough moisture available, and this is a system that's originating out of the Gulf of Mexico, so therefore it's got a lot of moisture associated with it. And from that standpoint, we do expect that there could be some precipitation that could have a convective element to it based on this as well. We do know that that's moving in, so when we get to 21Z, you can see that speckled area of vorticity pattern that you see color-wise all through that region as that next upper level trough moves in. If we look at the 700 millibar charts, this allows us to see what's happening around 10,000 feet. But specifically, I want to look at this omega field, which is a really a good indication of whether or not how much you're going to have in terms of upper levels or support from the lowest levels into the mid levels of the atmosphere. And you can see right here, anywhere you see this red area here, this is what we call negative omega. And anytime you see this concentric ring here, that means you have pretty good wide scale or what's called a vertical ascent in the atmosphere. Again, this is not like an updraft in a thunderstorm, but a vertical ascent across a large area. So that in of itself gives us another indication that as of 18Z, there is some weather that's moving up there that has some support for vertical movement. And in addition, you can see that you've got a lot of this green area here, which is relative humidities, and relative humidities in the dark green areas are going to have a lot of moisture. So this has got certainly some moisture associated with it, and therefore we'd expect out of this for this to be a pretty significant weather system based on this. And if we move this over through until 21Z and 0Z, you can see, wow, it starts to really crank up big time there, where we have all that red concentric circles there, which shows a lot of a large-scale ascent in the weather in that area. So it is in a process of trying to increase, or at least we're looking at this as being a system that is developing in a developing state, and therefore, again, I prefer, if I'm going to challenge a weather system, I don't want to challenge one that's actually in that state of intensifying. And we can look at the upper level charts to see if there's any really high level support here. In some cases with these weather systems this time of year, there can be a fairly significant upper level support here in that sense. And what we do see is that we see what's called a jet streak. And it's not really all that significant, but it's enough that you can see that here. So here's our upper level trough. This is up at 34,000 feet, kind of the tops of this weather system. And you can see here there's this area that's a faster flowing air. And again, that helps create upper level divergence. We call this a jet streak, and that's another indication that we have, again, some upper level support with this. And that's what I'm trying to do is get that big weather picture in my head so I can thoroughly understand what is occurring, and gives me an idea whether or not I should probably wait this out, or maybe even go a little earlier in this particular case to beat the more significant weather, which is really looks like it to be the what we're looking at for this particular trip. Let's take a look at the convective outlooks from the Storm Prediction Center here, and we'll get an update here on where the Storm Prediction Center is thinking there's going to be some possible thunderstorms. This green area that you see here, and we do know that that's where a lot of the convection is expected to be, but this is over a 24-hour period. Not very helpful unless you're flying in an area where it's white, where there's no convection, but our route takes us kind of right through that region, and therefore the possibility of seeing convection in that area in that 24-hour period is pretty likely. If we further kind of quantify this, we can look at the thunderstorm probability forecast from the SHREF, which is the Short Range Ensemble Forecast. And this will, again, allow us to see a higher resolution in time where this weather system is expected to develop. And we know that most of that is going to be down here off the coast of Texas up into Louisiana early on in the picture, and that's expected to eventually work its way up a little bit further north with time. So it looks like later on is not as good, but certainly earlier on is a little bit better in terms of keeping that convective element further to the south. The other thing I'll look at too, and gives us a little bit better understanding, is look at the gridded MOS product, model output statistics from the localized aviation MOS program or LAMP. And that will, again, give me an understanding from a convective standpoint what we're looking at. And so this is what's called the convective potential here. And this is an hourly product, and it goes out pretty far in time. Certainly by the time we get to 1718Z, you can see how most of it again is further south, and that's moving up into the parts of Louisiana here, and most of it stays to the south in terms of that overall convective potential before it eventually starts to work its way gradually up to the north and east with time. So most of that convection along our route will probably likely happen. And this red area here, I know red, it's odd you think that would be the worst, but it's considered low convective potential. And in the EZWxBrief Progressive Web App, we do something very similar for the departure advisor and personal minimums. But this definitely tells us that we have over the period of from about 1617Z, we're working into an area here where we're starting to see some convective potential. Is it a thunderstorm? Well, we can look at the lightning potential as well and see if there's anything there. So let's move that over to about the same time frame. And right now, you can see that there's really no lightning potential, or very little. A lot of this may be because of the time of year and also the fact that these are probably lower cloud tops. And so there's not a lot of situation where you're going to see lightning associated with this. So you're not going to see any forecasts typically in the terminal forecasts for thunderstorms just because there's not a chance of lightning. You'll see instead showery precipitation showing up there as well. If we look at the HREF model, and specifically I want to look at go down to the south central area, and we're going to look at the ECOTOPS product, which is the ECOTOPS forecast for 30,000 feet. And this is a probabilistic forecast. And you can see that there's really the tops of the precipitation core are in the green area, which means there's a really low probability. And that's another reason why we're probably not seeing much lightning in in this particular system. But you do notice that as time moves on, you see a few blue areas here where you might see a cell or two that pops up near 30,000 feet. But most of this is going to be all low-topped convection if it does develop. But let's take a look at the forecast radar for this area. This is from the high-resolution ensemble forecast. And what we'll see here is, again, something very similar to what we were seeing in on the map for the high-resolution rapid refresh model. You can see by the time we get to 20Z or so, our Little Rock is in the center here, and our trip is from this direction up through here. We're starting to see these returns, the forecast radar returns, again be pretty significant, which tells us that over the time we expect that weather to essentially start to become worse with time. So we're going to see the intensity of the system start to take shape by the time we get to early afternoon hours and moving in. So even a couple of cells may be ahead of that. You can see here, even at 13Z or so, maybe a couple of intense cells moving in that region before the main core of the system moves in by the time you get to 20Z, and that's when we're expected to land. So this again tells me that I don't want to probably be fooling around with the system at 20Z. That's when things really get pretty bad. The other model I look at is this HRW, which is high resolution window, FV3 model. And specifically, I like to look at the composite radar depiction. And I'm trying to look at all these different products to see in weather guidance to see how similar they look. And do they tell me the same story, or is there different stories being told? When they tell me the same story, I've got a pretty good idea that, all the forecast models all lining up together tells me the same story. That gives me a lot of confidence that most likely they have a pretty good feeling for what the weather's going to do. So once again, at 18Z or so, looks pretty good, but ultimately by 20Z and 21Z, that weather moves in. And I would probably be much in there. There is a little bit of that's probably the initial warm front here moving through that region with some of that upper level vorticity helping to get that started. but that's what we kind of are looking at and expecting here. I also want to take a quick peek and look at the airport weather. Specifically, let's look at Little Rock, which is our destination. And this is the 1 day view in the meteogram. And just to do a quick peek and see what the terminal forecasts are here. This is not surprising. Essentially, in the overnight hours, they're expecting some showers in the vicinity. That's that first wave possibly coming through, and they're looking at it as showery precipitation. But by the time they get to 14Z or so, they're only showing rain. And that was also, we saw that on the map. We didn't see any shower symbols. We saw rain symbols, so basically non-convective kind of rain at this point in time. So not much going on there in that sense. We could also look at the forecast discussion, several different places here. I like to read through this after I've gone through and looked at that big weather picture. And this says a broad surface high pressure was analyzed over the greater southern or eastern U.S. and Gulf coastal region with the northern periphery of an anticyclone surface flow lying across the local forecast area, driving primarily southwesterly winds. That southwesterly winds are from a warm and moist source. Through the remainder of Saturday afternoon and evening, expect settled and warm clouds, warm conditions, some increasing cloud cover noted from southern to northern Arkansas. The main talking point through the short term remains increasing rain chances through late Saturday night and Sunday as a surface warm front advanced northward in conjunction with an approaching compact H500 is the 500 millibar level trough, prone to eject into the southern plains. That's what we saw with that trough moving in. And QPF amounts with this system have trended down locally, as evidenced by recent model guidance, including 12Z HREF, which is indicative of the primary rainfall axis. So ultimately, it's kind of telling us exactly what we already know, not a lot of information. And generally speaking, in the aviation section down here, it really doesn't talk specifically about anything in terms of whether or not they're just saying there is some potential for thunderstorms Sunday afternoon over southeastern Arkansas. And we saw that where the southeastern Arkansas tends to be the most significant area of convection for that time. Let's go back again to the meteogram so we can see what's happening here. And it's very common when we look at the cloud depiction. The clouds here are pretty deep overall, and the time frame we're looking to land here is probably in the this particular time frame. We know some of those tops are all the way up there near 40,000 feet, and it's very common as time moves forward here. Think about what's happening at that airport. It's very common for the high clouds to move in first, and finally they start to eventually build down and become more significant over time as that weather system moves through. And this cloud depiction here in the meteogram tends to agree with that as well. And let's look at the route profile real quick to see the route itself and see, hopefully, better understand what's happening here. So there's our direct route of flight at 10,000 feet, and we're going to open that in the profile view. So we can see things, for instance, like what's happening with the freezing level along that route, whether there may be some icing concerns, and also kind of generally look at the cloud depiction along that route. And so this shows us if we were at 10,000 feet that we would have, for the most part, a headwind all the way there. And if we look at the cloud depiction, our departure airport looks pretty good overall, but as we get closer to our destination, you can see that ceiling dropping down as that weather system moves through, with a fairly significant deep weather system here up to 35,000 feet, which gives you an indication you've got a pretty powerful system. And even by looking at the time frame here, if we move this to 18Z when our planned departure would be, really not much of a difference there. We go a little earlier, it's a little bit better from that standpoint. So if we leave here, for instance, at early in the morning at maybe 13Z, for instance, in this particular case, the cloud cover is still there, but overall we have the notion that we're going to be dealing with a freezing level here around maybe 10,000 feet. It looks like it goes all the way through to our destination. So if, again, we don't want to be in a situation where we're above that area because we're likely to pick up some ice. And you can even see here, I've got the SLD turned on there, and you can see that we have here a pretty good chance of even some SLD showing up in that region, which gives us another indication that we've got a fairly significant area of icing potential above about 10,000 feet. So we definitely don't want to be looking at it from that standpoint. We want to take make sure that we're not flying above that without a certified ice protection system. And even then, we probably don't want to be flying the entire route in icing conditions, especially later in the time frame where we're expecting that weather system to move in, and you're going to start to see more in the case of heavier icing in different spots. Now, turbulence-wise, turbulence only goes out to about 18 hours in the future. Doesn't look like much. Overall, looks like maybe some moderate turbulence, but as far as a significant ride, doesn't look really bad. But if you get into a cell or two, especially an embedded cell, you might pick up a lot more significant turbulence than what's showing here in association with that. So I think overall, what we're seeing pretty clearly is there's probably little or no doubt that the weather system is in an intensification mode at this point. So we're not going to be in a situation where we're headed toward a dissipating area of weather. Instead, we're looking at a strengthening area of weather. So the entire region along our route, especially near our destination, is expected to worsen with time. So in this particular case, I would probably plan to get up earlier in the morning and do all our pre-flight analysis early in the morning, and probably try to get out before this started if I certainly have the schedule to do that. That's really what we're looking at from this particular situation. So thanks again for tuning in, and we'll talk to you again real soon.